All right, hey everybody. Happy Monday, GNU Radio Conference. Good to be here with you after a couple of years being away. My name is Matt. I'm here representing Sid and Marc. We're going to talk about the Radio Resilience Competition, which is a new type of virtual CTF that we're going to be running here at GRCon this year. So the Radio Resilience Competition was sort of envisioned by Sid Sijbrandij, who founded Radio Resilience LLC. In a completely separate context, Sid is also the founder and CEO of, co-founder and CEO of GitLab. This activity with Radio Resilience is completely separate from that, has nothing to do with that, so just want to put that up front. Sid has reached out to myself and Marc Newlin, who are the co-founders of Agitator, a wireless and security consulting company, to help him put together this competition and run the event. So we're happy to be here representing Sid in that capacity. And if you want to reach out to us, you can email us. It's just our first names at radioresilience.com if you want to track us down after this. So we're going to briefly run through sort of the motivation and background behind this competition, why we wanted to run this after many other wireless competitions have been run, what we think we're bringing to the table, and why we think it's exciting. We'll tell you a little bit about what we've learned from competing in past SDR challenges. And then we'll tell you about the Radio Resilience competition that we're going to be running here this week at GRCon. And I'm going to try to encourage you to compete, because it's going to be fun. And we'll wrap up with a demo. So first, I'd like to start with a message from Sid, our sponsor. So here we go.
For that, Matt. I've been running a software business for the last couple of years. But I also studied applied physics. And I had to go back in my 5th year of studying and go back and do one course that was left of my first year. It was electricity and magnetism. It was the hardest thing to do. And I never imagined myself going back to that. But when I found software-defined radio, I was hooked. It was super interesting and it's super approachable. So as I started getting into it, I found GNU Radio, which was awesome. But I also discovered the DARPA SDR competitions, the Spectrum Challenge, and the Spectrum Collaboration Challenge. And that got me thinking. And got me thinking about the progress in radio. Because I think one of the biggest benefits has been unlicensed spectrum. Now that we have unlicensed spectrum, where you don't need permission to broadcast, there's been so much innovation. I cannot live without Wi-Fi. And it's working because devices are well behaved. But I think we should put the bar higher. On the internet, we don't assume that everyone is well behaved. And I think that as things get bigger and there's more users and more devices, that will be the case for the radio spectrum as well. So we gotta make sure that radio works, even if people are intentionally trying to interfere. And when we have protocols that can deal with that, I think it will make radio work better, also when there's no interference, because it will just be more reliable, period. And to get there, I think a competition is a great way.
Cool. So a little background on Sid's motivation for starting the RRC here. So what brought Marc and I sort of to Sid's attention was Marc and I competed in DARPA's Spectrum Collaboration Challenge that ran a couple of years ago. If you all have been coming to GNU Radio Conference or following the space for a couple of years, you probably saw this a few years ago. I know some of the some people that were involved in organizing the competition are here today. I see you, Craig. Hey, Craig. So Marc and I competed as a individual team. We were Team How Make Radio, because we were scrappy and sort of coming at it as 2 individuals. And the SV2's objective was to develop collaborative radio links that wouldn't interfere not only with themselves, but with other radios in the environment. And it was a really cool competition. They built some amazing technology. It was very complicated, though. So it was a very complicated game structure. Scoring was complicated. The number of variables that we were optimizing for, like the state space, was so huge. DARPA built some really incredible infrastructure, which was also pretty complicated. And some of the downsides there was it meant that we had a very slow iteration time. It would take upwards of like 30 minutes to get back 10 minutes of data. And there was also a lot of sort of like bespoke development that went into developing for this really powerful, very complicated hardware testbed. So coming out of this, we definitely learned some, or picked up some things that we knew we wanted to sort of, reflect in this competition, and things that we wanted to sort of build on as well. SC2 definitely reminded us that the Phi was still a space where there was a lot of work to be done. If you looked at like the types of Phis that different competitors were building, they all looked very different. There was a lot of OFDM, but there were also some other sort of like more off the wall things that were kind of cool. So we figured there was still plenty of room to run here on just the Phi. We also wanted to optimize quite a bit for the infrastructure and sort of ease to build and develop on, so that we can lower that barrier to entry and get more people involved. And in doing so, we wanted to tighten up the development life cycle, or excuse me, the development cycle, so that competitors could iterate really rapidly and locally on their designs before running them sort of in the larger centralized infrastructure. So that brings us to RRC, which I'm excited to tell you about right now. So the radio resilience competition is a new kind of virtual CTF, and our key objective here is to improve the state-of-the-art of resilient radio links. If you've heard of RRC, maybe you heard us talk about it last year. We announced it at GNU Radio-Conference 2020, and we soft launched it last fall with 6 teams. We ran sort of 5 like warm-up events called scrimmages, and then had a final event where we had a number of different scenarios and sort of put together all the things that we built up to till then. And in spring 2021, we ran another series where it was more of a like a continuous competition. Rather than having these sort of like events that we focused our efforts on, we built more automation so that we would run daily matches and automatically publish the scores on a daily basis, so that competitors could iterate and see that improvement day after day. So why should you compete? Well, we're at GNU Radio Conference. RRC is built on GNU Radio. I'll tell you more about the infrastructure when we get a little bit more into it, but GNU Radio is all over the infrastructure that runs this thing. It's also fully open source. So the infrastructure is open source, and Sid, being a big believer in open source, is asking that all competitors open source their submissions under an OSI-approved license. Again, just fostering the spirit of collaboration and innovation. And also, it's fully virtual. So given that this is a unique event, a unique year where a couple hundred of us are here in person, a couple hundred of us are virtual all over the world, this is a CTF that we can all compete in, whether we're here in Charlotte or if we're just on the internet too. And everybody's on equal footing in that regard. So if you want to compete, we've got a couple events that we're going to be highlighting throughout the week here. First thing you should do, if you're even remotely interested in competing, hit that link up top, radioresilience.com. There's going to be a link from that page to register. Go ahead and register right now, and that'll kick off some things in the background that will stand up the infrastructure for you to submit your image if you decide to build one and submit it later. So do that now, get that out of the way, and you'll hear from us with some more information. So other events, sort of how the week is going to go. We're featuring 3 rounds. The submissions are due Monday, Tuesday, and Wednesday at 6 p.m. Submit your image before 6, and we'll run it overnight, and then we'll provide your update sort of in a daily leaderboard. We'll post the results online prior to the lightning talks we're going to give, so you can check back earlier in the day to see how you did and make changes and things like that. But we will do a daily check-in as well, where we'll talk about how things are going, what we're seeing, that sort of thing. I'm also going to be here in person today and tomorrow, and then we're going to be, online, virtual on the GNU Radio Matrix channel on our own Slack as well for any, help and questions and things like that you might have. And then Thursday at 4:30, we're going to announce the final results as well. We've got some great prizes this year. So if you win, one lucky winner will take home a B205 Mini and a MacBook M1 Pro. MacBook Pro M1. There you go. So some pretty sweet prizes. It's a pretty sharp, SDR development rig there for you, for whoever comes in first. Terms and conditions apply. US residents only, unfortunately, due to like tax and contest laws and stuff like that. Stuff the lawyers figured out. And see our website for all the full terms, but nothing too crazy there. So how does RRC work? So RRC takes place in a fully virtualized testbed that we call the simulator, very creative name. In the simulator is an environment where basically what we have is we have GNU Radio running in a number of different Docker microservices that are all orchestrated with Docker Compose. Docker Compose is basically a framework for running different Docker images sort of in concert with one another. Provides some networking and some other sort of glue that makes all that nice. The signal processing is primarily in GNU Radio and Liquid DSP, and we provide a fully working environment, including a submission-ready image out of the box. So if you git clone the simulator and just run the build script, you're ready to compete. Obviously, you can then take that and build on it, tweak the knobs, make it perform better, but we really wanted that on-ramp into the competition to be as friendly and accessible as possible. So for local testing and development, the environment is fully reproducible locally. It requires, I believe, Ubuntu 20.04, but you can run it on your laptop. It does not run in real time, so you do not have to have a beefy machine. The simulator is like sample synchronous and will slow itself down to match whatever hardware you're running it on. For the competition, however, we're going to take your image and run it on an EC2 box that we have. Everybody runs in the same box. And then we'll post your results and logs and things like that somewhere where you can pull them down the next day. If you want an architecture diagram, here's what it looks like. There are 5 different kinds of microservices. Only one of them you will be developing code for. So where you see those 2 blue arrows, points to 2 microservices called the Blue Radio container TX or RX instance. What we're going to do is we're going to take the image that you build, and we're going to create 2 instances of it. And the traffic flows for scoring purposes from the transmit radio to the receive radio. All of the IQ that's being generated is getting, by these different microservices, gets pushed into this microservice called the channel emulator, which takes all those IQ streams, muxes them up, and then redistributes the product out to all the other microservices for ingestion, reception, decoding, traffic that interferes with the blue radios, et cetera. And if you want to get more into detail, we really break all this down on the website. There, if you go there and then you click on the go to the radioresilience.com and then click on the competition page, we break down the architecture and what these different microservices do in a little bit more detail than I can provide right now in 25 minutes. But so the key takeaway is that there's all this stuff happening in the background, but the only 2 things that you're touching are those blue radios. So the rules are also available online. But basically our traffic marshal container, the one on top, it's a container that we control that you don't touch, is going to generate a number of packets for your blue radios to deliver to each other. What the packets contain is a sequence number, a bunch of pseudo-random data, and then a signature. And what we're doing when we receive a packet back from you is we're checking, first of all, to see if that signature matches, and then to see if we're getting contiguous sequence numbers from you. And if you drop a packet, that caps your score. So basically, your score at the end of this is equal to the highest contiguous sequence number that you receive. And the reason why we do that is because we want to incentivize the development of really reliable radio links. So you could deliver, if we send you 1,000 packets to deliver, you drop the first one, and then you deliver the 999 that follow, I'm sorry, your score is 0. But if you deliver 998 and then drop, the penultimate packet, then your score is 998. So again, you're just going to be modifying those 2, the blue radio microservice there. Those are the paths in the simulator, the ones in bold there that are going to be interesting. Everything else is just there to run the environment, but those are the things where you're really going to focus your attention when you go to do your development here. And again, just to highlight, we're providing a fully functional node to get you started. You don't need to make any code changes to compete. If you want to just build it and then resubmit that image, you will be entered and eligible to win that prize, assuming you meet all the other terms, things like that. I do encourage you to make some code changes because the stock image is not very good. This is what our interference scenario looks like. I mentioned that we're here to develop resilient radio links. To make it interesting, we do have some different scenarios that sort of shake up the channel that your radio will have to find different ways to get around. This interference pattern, if you can, I don't know if you can see with the contrast on the screen, but basically what you'll see is there's an interferer that's pulsing on and off periodically. It's also getting stronger as the match goes on. So the first pulse is kind of weak. You can see it's sort of blending in with the top of the baud line interface there. And then towards the bottom, it's pretty strong. So you have an interferer that's getting stronger as the match goes on. You also have some time-based elements that you can maneuver around if you want to like stay quiet when the interference is on and then try to sneak a bunch of traffic through when it's off. You can get clever like that. As of now, we'll see how everybody does with this, but the plan is to just run this one scenario all week. If people are struggling with it, we might make it easier, but this is the plan for this week. So to get started, go to radioresilience.com and register. Go to the website and read about the terms, the architecture, the rules, and things like that. And if you want some help getting started, we're doing an optional workshop somewhere around here at 3:30, so 30 minutes after this talk ends. I will be there in person. Marc will be online to help out with any online support, things like that you might need. In parallel, you can clone the simulator, gitlab.com/radio-resilience/simulator. Pull that down, follow the README. It's got all the instructions you need to build and run the simulator, to build your first radio image locally and run a full match locally as well. And then after you complete that first registration step, what we're going to do is we're actually going to make a GitLab project for your team. And the reason why we do that is because each GitLab project brings with it its own unique container registry, and that's how we're going to take your image. So what you're going to do is you're going to push your image up to that GitLab container registry, and then we're going to pull it down when we go to run and evaluate it. When you register, you'll get sent instructions on how to do all this. It's pretty straightforward. If you have any trouble with it, we're here to help you out with it. And then we want you to iterate on this too. So make changes to your blue radio locally, run it, see what happens to your score. Score goes up, that's great, keep going that direction. Score goes down, maybe try something else. And then daily we're going to be running those matches. You can pull down your logs and things like that to see how it's running in our real environment, which for all intents and purposes should be identical to your local environment, but your logs will be available too. And we also will render your IQ and sort of sync up your score in real time, and you'll be able to watch that on the website on our leaderboard as well. And we also want to sort of foster a community of collaboration here too. So we have a Slack channel we'd love to invite you to. Feel free to jump on there and share ideas. If you want to try to find people to team up with, by all means. And then if you have any technical support questions, we just ask that you submit those on the Simulator GitHub project as issues so that we can sort of answer them once for everyone. I'm going to roll a quick demo, pre-recorded, and I'll narrate as we go here. Okay, so what we're going to do is we're first going to modify the base image, the base blue image. So the font's a little bit small, but what we're doing is we're turning down the modulation to PSK2, and we're turning off all the FEC, and we're going to run it, and we're going to see a score. And then we'll tune up the knobs, and we'll see how the score improves. And we'll show sort of the cycle of how you can run these images locally and get feedback from them. This is on fast forward because the match takes a little while to run. Here you can see the interference pattern sort of on the right-hand side of your screen, pulsing on and off. You get your big PSK2 channel in the middle there that's just plugging away, doing its thing. For the purposes of time, I might try to skip ahead a bit because otherwise we're just watching log scroll, and who wants that? There we go. Score 1,780 at the bottom there. So we're going to make some changes here to the configuration of the radio, and we'll run it again and see how we do. So we're going to turn up the modulation of PSK4. We're going to add some pretty basic FEC, 2 layers of FEC, and then we'll run it again and we'll see how we do. And off it goes. There goes the radio again, and I'll skip ahead for time. If I can. Multimedia on Linux is always a bit of a journey. Well, I'll let this run, but take my word for it, the score goes up. So you can pull down the simulator, get started with it locally, join the workshop if you have any questions about getting started or just want any help. And I really hope that you'll consider competing. We think this is going to be a fun addition to the GNU Radio conference program, and we hope you all enjoy it. Let me just find my slides as we wrap up here. And I think we are done. Let's see. Nope. There we go. Workshop at 3:30. Come find us if you want to play, either in person or virtually. Go to radioresilience.com to register. And thanks so much. Hope you'll consider playing.
All right. Thank you, Matt.